Hello everyone, and welcome. Have you ever wondered which element on Earth is the most expensive? Many people immediately think of gold or platinum. Others might even guess diamonds. But the truth is far more surprising. Some of the world's most valuable elements are so rare that they exist only in microscopic amounts, and some cannot even be found naturally on Earth. Instead, scientists must create them using advanced nuclear technology, a process that can take months or even years. In this video, we'll count down the 7 most expensive elements in the world. Along the way, we'll discover why these extraordinary elements are so valuable, how scientists produce them, and how they are helping advance medicine, technology, energy, and scientific research. One important note before we begin. The ranking in this video combines approximate production cost, rarity, and scientific value. While naturally occurring precious metals such as gold and rhodium have market prices that change every day, some synthetic radioactive elements are produced only in specialized research facilities and are not sold through normal commercial markets. Their estimated value reflects the extraordinary cost and complexity required to create them. With that in mind, let's begin our countdown. Number 7, Gold. For thousands of years, gold has symbolized wealth, beauty, and prosperity. Although it is the least expensive element on today's countdown, it remains one of the most valuable naturally occurring elements on Earth. Gold, with the chemical symbol O and atomic number 79, is a transition metal known for its brilliant yellow color, remarkable resistance to corrosion, and exceptional ability to conduct electricity. Unlike many metals that react with oxygen or moisture, gold remains stable for thousands of years. Ancient gold artifacts recovered by archaeologists often appear almost unchanged despite being buried for centuries. While jewelry accounts for much of the world's gold demand, modern technology also depends heavily on this remarkable metal. Gold is used in smartphones, computers, satellites, spacecraft, medical equipment, and high-precision electronic circuits. Because it conducts electricity extremely well while resisting corrosion, it provides reliable electrical connections in devices where failure is not an option. Gold is also widely held by central banks around the world as a financial reserve because of its long history as a reliable store of value. Although millions of kilograms of gold have already been mined, finding new deposits has become increasingly difficult. Mining operations often require processing enormous amounts of rock to recover only tiny quantities of pure gold. Even so, compared with the extraordinary elements later in our countdown, gold is relatively abundant. Number 6, Iridium. Moving one step higher in our countdown brings us to one of the rarest naturally occurring elements on Earth. Iridium, with the chemical symbol Ir and atomic number 77, belongs to the platinum group of metals. It is considered one of the most corrosion-resistant elements known. Even exposure to strong acids, high temperatures, and harsh chemical environments has very little effect on iridium. This incredible durability makes iridium essential for specialized industrial applications where ordinary materials would quickly fail. Engineers use iridium in aircraft engines, spacecraft components, spark plugs, laboratory equipment, and scientific instruments that must operate under extreme conditions. Iridium also plays an important role in certain medical devices and advanced electronic technologies. Interestingly, much of Earth's iridium is believed to have arrived billions of years ago through meteorite impacts. One of the most famous geological discoveries involving iridium is the unusually high concentration found in rock layers associated with the asteroid impact that contributed to the extinction of the dinosaurs approximately 66 million years ago. Today, iridium remains one of the rarest elements in Earth's crust. It is usually recovered as a byproduct during platinum and nickel mining rather than mined directly. Its scarcity, combined with its extraordinary physical and chemical properties, makes iridium one of the world's most valuable naturally occurring elements. Number 5, Rhodium. As our countdown continues, we arrive at an element whose market price has frequently exceeded that of gold and platinum. Rhodium, with the chemical symbol Rh and atomic number 45, is another member of the platinum group of metals. Unlike gold, rhodium is extremely rare and is produced in only small quantities each year, primarily as a byproduct of platinum and nickel mining. Its greatest strength lies in its remarkable catalytic properties. A catalyst is a substance that speeds up chemical reactions without being consumed during the process. Rhodium is exceptionally effective at helping convert harmful gases produced by vehicle engines into less harmful substances before they enter the atmosphere. Because of this ability, rhodium has become one of the most important materials used in automotive catalytic converters. Demand for rhodium often depends on global automobile production and environmental regulations. When demand increases while mining output remains limited, prices can rise dramatically. In some years, rhodium has become several times more expensive than gold by weight. Beyond the automotive industry, rhodium is also used in specialized laboratory equipment, optical instruments, electrical contacts, and high-quality jewelry coatings that provide a brilliant reflective finish while resisting scratches and corrosion. Its unique combination of rarity and industrial importance has secured its place among the most valuable naturally occurring elements on Earth. So far, our countdown has focused on rare elements that nature created over billions of years. But the remaining elements are different. Unlike gold, iridium, and rhodium, they are not mined from the earth in meaningful quantities. Instead, they are produced inside specialized nuclear facilities through processes that push the boundaries of modern science and engineering. As we continue, the prices rise dramatically, from hundreds or even thousands of dollars per gram to estimates reaching millions of dollars for materials that only a handful of laboratories in the world are capable of producing. In the next part of our countdown, we'll explore the extraordinary radioactive elements that have transformed nuclear science and discover why creating just a tiny amount can require years of research, highly specialized reactors, and some of the most advanced technology ever developed. The remaining elements in our countdown are unlike anything we have discussed so far. They are not mined from rich underground deposits, nor are they traded on international commodity markets like gold or platinum. Instead, these extraordinary elements are produced through advanced nuclear science, often in quantities so small that they are measured in micrograms or milligrams rather than grams. Creating them requires specialized nuclear reactors, sophisticated laboratories, highly trained scientists, and years of careful research. Let's continue our countdown. Number 4. Tritium. At number 4 is tritium, a rare radioactive form of hydrogen. Tritium has the chemical symbol superscript 3H and is one of the 3 naturally occurring isotopes of hydrogen. Unlike ordinary hydrogen, which contains only a single proton, tritium contains 1 proton and 2 neutrons inside its nucleus. Although tiny amounts of tritium are produced naturally in Earth's upper atmosphere through interactions with cosmic rays, the vast majority used today is produced artificially inside nuclear reactors. Its production is both technically challenging and highly regulated. Tritium is valuable because it emits low-energy beta radiation while requiring no external power source. This unique property makes it useful in applications where long-lasting, reliable illumination is needed. It has been used in self-illuminating emergency exit signs, scientific instruments, and specialized military equipment. More importantly, tritium plays a significant role in nuclear fusion research, where scientists are working toward developing cleaner and more sustainable sources of energy for the future. Because production is limited, handling requires strict safety procedures, and global demand remains specialized, tritium can be worth tens of thousands of dollars per gram. Its value comes not from rarity alone, but from its importance in advanced scientific research and nuclear technology. Number 3, Plutonium-238. Moving higher in our countdown brings us to one of the most remarkable materials ever used in space exploration. Plutonium-238 is a radioactive isotope of plutonium specifically valued for its ability to produce heat continuously through radioactive decay. Unlike plutonium-239, which is associated with nuclear weapons and reactors, plutonium-238 is produced primarily for peaceful scientific purposes. Its greatest contribution has been powering spacecraft exploring the most distant regions of our solar system. Far from the Sun, solar panels receive too little sunlight to generate enough electricity. To solve this problem, engineers developed radioisotope thermoelectric generators, often called RTGs. Inside these generators, the heat released by plutonium-238 is converted into electricity, allowing spacecraft to operate reliably for decades. Some of humanity's most famous space missions, including the Voyager spacecraft, the Curiosity rover on Mars, and the Perseverance rover, have relied on plutonium-238 to continue exploring worlds millions or even billions of kilometers from Earth. Producing plutonium-238 is extremely expensive and time-consuming. Only a small number of facilities worldwide possess the technology needed to manufacture it, and production requires specialized nuclear reactors followed by complex chemical processing. Because of its limited availability and its critical importance for deep space exploration, plutonium-238 remains one of the most valuable radioactive materials ever produced. Number 2. Einsteinium. At number 2 is one of the rarest synthetic elements known to science. Einsteinium, with the chemical symbol Es and atomic number 99, belongs to the actinide series of the periodic table. It was first identified in 1952 after scientists analyzed radioactive debris from the world's first hydrogen bomb test. Later, it was named in honor of the renowned physicist Albert Einstein. Unlike naturally occurring elements, Einsteinium exists only because scientists create it through carefully controlled nuclear reactions. Producing it is an extraordinary scientific challenge. Heavy elements must be exposed to intense streams of neutrons inside specialized nuclear reactors. Afterward, scientists spend weeks or even months separating microscopic quantities of Einsteinium from many other radioactive materials. The total amount produced worldwide is incredibly small. In many cases, researchers work with samples weighing only a few micrograms. Because production is so difficult, and because the element is highly radioactive and gradually decays into other elements, Einsteinium is used almost exclusively for scientific research. It helps researchers investigate the chemistry of heavy elements, understand nuclear structure, and develop even heavier synthetic elements that continue expanding the periodic table. Although it has almost no commercial applications, its scientific importance makes it one of the most valuable elements ever created. Number 1. Californium-252. Finally, we reach the top of our countdown. Californium-252 is widely recognized as one of the most expensive substances ever produced. This remarkable radioactive isotope belongs to the element californium, which has the chemical symbol Cf and atomic number 98. What makes californium-252 so extraordinary is its ability to emit an exceptionally large number of neutrons naturally. These neutrons make it an incredibly powerful tool for science, medicine, and industry. Californium-252 is used to help start certain nuclear reactors, detect valuable mineral deposits deep underground, inspect industrial equipment without damaging it, and support specialized forms of cancer treatment involving neutron radiation. Scientists also use it extensively in nuclear research because few other materials can provide such an intense neutron source in a relatively compact form. Producing californium-252 is one of the most demanding tasks in nuclear chemistry. The process requires years of neutron irradiation inside specialized reactors, followed by highly sophisticated chemical separation performed under strict radiation safety conditions. Worldwide production amounts to only tiny quantities each year. As a result, estimates suggest that a single gram could be worth tens of millions of dollars, making californium-252 one of the most expensive materials ever created by science. Its extraordinary value reflects not luxury or beauty, but the immense scientific effort required to produce it and the unique capabilities it provides. Our journey through the world's most expensive elements reveals an important scientific lesson. The true value of an element is not determined simply by how attractive it looks or how much jewelry it can create. Instead, value often comes from rarity, the difficulty of production, and the remarkable properties that allow scientists and engineers to solve problems that no other material can. From gold preserving wealth for thousands of years, to rhodium helping reduce vehicle emissions, to plutonium-238 powering spacecraft across the solar system, and finally to californium-252 advancing medicine, industry, and nuclear science, each of these extraordinary elements demonstrates a different way chemistry continues shaping our modern world. Thank you very much for watching. If you enjoyed this journey through some of the rarest and most valuable elements ever discovered, please consider giving this video a like, sharing it with friends, and subscribing for more science-based videos about chemistry, physics, astronomy, and the incredible discoveries that continue expanding our understanding of the universe. Thank you again for your support, and we look forward to seeing you in the next video.